I am Dr. S.M. Khaina, Professor and Head Department of Applied Sciences, MIT Academy of Engineering, Alandi, today. Today I will speak on differential equations for engineering science. Some common views about the mathematics. Most of the people at world level, they are saying mathematics is hard, mathematics is boring, mathematics has nothing to do with real life, and mathematics has no applications. But I tell you that maths is important in most of the branches of engineering, crime detection, then pharmacy, then management, medicine, and almost everywhere. So outline of topic is introduction to ODE, that is the ordinary differential equation, ordinary differential equation and partial differential equation, classification of ordinary differential equation, initial and boundary value problems, analytical and numerical solution, modeling, that is the how to form the physical and the mathematical modeling, and what should be the approach of engineering students towards differential equation. So these are the learning objectives. So we have to recall the basic definitions of ordinary differential equation. We should know what is the order of differential equation, degree of differential equation, linearity, initial conditions, and how to find the solution of differential equation. How to classify the ordinary differential equation based on the order, linearity, and the condition, and how to classify the solution of differential equation by various methods. So look at here, how to differentiate the ordinary derivative and partial derivative. If v is a function of single independent variable, then it is the ordinary derivative. U is a function of more than one independent variable, then this is the partial derivative. So here you will understand the difference between the ordinary and partial derivative. Look at here how to differentiate the ordinary differential equation, generally, or it is popularly known as ODE, and the partial differential equation. Look at the first example, d square v by dt square plus dt is equal to 4. It involves one or more ordinary derivatives of unknowns. So here v is called as the dependent variable, which is also called as the unknown function, and t is the independent variable, and hence it is the ordinary differential equation. So basic concept, that is the why ordinary word is appeared. So it is a function of single independent variable. Look at the second example, dava square u by dava x square minus dava square u by dava y square is equal to 0. It involves one or more partial derivative of unknown functions. So here u is the dependent variable which depends on two independent variables, that is x and y. And here you will understand the difference between the ordinary differential equation and the partial differential equation. So what is ordinary differential equation? Popularly known as ODE, which involves one or more ordinary derivatives of unknown function with respect to one independent variable. If you look at the example, dv by dt plus dt is equal to 0, that is the first order and first degree differential equation in D, where v is dependent variable and t is the independent variable. Look at the second example, d square x by dt square plus 6 dx by dt plus 2x is equal to cos t. So here, this is the second order differential equation in x. Here x is the dependent variable and t is the independent variable. So these are the two examples which you can understand the concept of ordinary differential equation. So x of t is the unknown function. It is also called as the dependent variable, and t is the independent variable. So what is the order of differential equation? These are the different terminology to understand the concept of differential equation. First is the order of differential equation, and second is the degree of differential equation. So the order of differential equation is the order of highest derivative involving in it. So if you look at the example, example, dx by dt minus x of t is equal to e raised to t. It is the first order differential equation. Look at the second example, d square x by dt square plus 4 dx by dt plus x of t is equal to cos of t. It is the second order differential equation. And third example is also define the order of differential equation. And the degree of differential equation is the exponent of highest derivative occurring in it. Is the index of, it is also called as the index of highest derivative involving it. So if you look at the first example, you will find it is the first order and first degree differential equation. Second, it is the second order and first degree differential equation. Third is the second order and third degree differential equation. So it is very important to understand this terminology to go ahead or to study the differential equation, that is the order and degree of differential equation. So what is the solution of differential equation? The solution of differential equation is a function that satisfies the equation. So generally, if we study the ordinary differential equation, then we have to go for the general solution and the particular solution. So the general solution of ordinary differential equation, it involves the number of arbitrary constant which is equal to the order of differential equation. So if the order of differential equation is 1, then its general solution contains one constant, let us say C1. If the order of differential equation is 2, then its solution contains two arbitrary constants, maybe C1 and C2. So particular solution can be obtained from the general solution by putting some particular values of that arbitrary constant, and the values of arbitrary constant can be obtained from general solution. So this is the basic difference between the general solution and the particular solution. So what about the linear ordinary differential equation? Because linear differential equation need to plays a very important role in engineering sciences, that is almost in all branches of engineering. So a linear differential equation is the ordinary differential equation which is the unknown function and its derivative appear to power 1 and no product of unknown function and its derivative. So the degree of differential equation must be 1 and it should not be the product of their derivative. So these are the examples. Look at the first example, dx by dt minus x of t is equal to e raised to t. It is first order, first degree differential equation, and it is a linear differential equation popularly known as LDE. Look at the second example, it is the second order, first degree differential equation. It is also linear differential equation. But look at the third example, you will find it is the second order and third degree differential equation, and hence it is not the linear differential equation. So if you look at these three examples, you will understand what is the linear differential equation and what is the non-linear differential equation. So non-linear differential equation is also called as the Bernoulli's differential equation. We don't have a direct method to solve the non-linear differential equation. So generally we reduce that non-linear differential equation to linear differential equation and then we find its general solution. This is the solution of ordinary differential equation. It is the second order differential equation and the solution is the particular solution. I already told the particular solution can be obtained from the general solution. And the most important thing as far as the differential equation is concerned, that is the uniqueness of the solution. Whether the differential equation has a unique solution or not. So in order to uniquely specify solution of nth order differential equation, we need n condition, because that is the concept of general solution. If the order of differential equation is n, definitely its general solution contains n arbitrary constant, maybe C1, C2, C3, C4, dash, Cn. Look at this example. This is the second order differential equation, and definitely two conditions are needed to uniquely specify the solution. So what about the auxiliary conditions? Because if you want to find the particular solution of any differential equation from general solution, so we need either initial conditions or boundary condition. So we should understand the difference between the initial conditions and the boundary condition. So what do you mean by initial conditions? That is, all conditions are at one point of independent variable, and boundary condition means the conditions are not at one point of the independent variable. Suppose x of 0 is equal to 0 and x of 0 is equal to 1, then that is called as the initial condition. X of 0 is equal to 0 and x of 5 is equal to 1, then that is called as the boundary condition. So we should understand the difference between initial and boundary condition for finding the particular solution. So look at here, initial value problems and the boundary value problems. Here you will understand x of 0 is equal to 1 and dx by dt at 0 is equal to 2.5. So that the point is same, and that's why it is the initial value problem, because the auxiliary conditions are at one point of independent variables. And if not at one point of independent variable, that is more than one point of independent variable, then that is called as the boundary value problem. Because as far as the differential equation is concerned, we know initial value problem and the boundary value problems are there. This is the classification of ordinary differential equation. So ordinary differential equation can be classified in different ways. So first is order, second is linearity, and third is the auxiliary condition. So as far as the order is concerned, whether it is first order differential equation, second order differential equation, or nth order differential equation. Linearity, whether the differential equation is linear or Bernoulli's, it is also called as non-linear differential equation. Whether if you want to find a particular solution of the any differential equation, whether the initial value problem is there or boundary value problem is there, that is very important. So these are the analytical solutions. So generally we find two types of solution. One is the analytical and second is the numerical solutions. So analytical solution to ordinary differential equation are available for linear ordinary differential equation and special classes of non-linear differential equations also. So numerical solutions, if you want to find the numerical solution, then we have to use the different numerical methods. The most important part as far as the differential equation is concerned, that is the modeling. So there are two types of modeling. One is the physical and second is the mathematical. So exactly what do you mean by the physical versus mathematical modeling? So if it is physical modeling, means model is trained directly within the system where the real process of interest takes place. So that is the, we should know the physical phenomena of that problem. Mathematical modeling means the model itself is trained through simulation on a computer or the mathematical formulation is involved. Means in mathematical modeling we have to form the model maybe through differential equation. The most important part as far as the engineering is concerned, generally in 80% examples we form the modeling via differential equation. So these are the three different steps which are involved to find to form the modeling. So look at this how to form the modeling via differential equation. So first of all, the physical problem is given. Then we have to identify the important variables. Then we have to make the reasonable assumptions and approximation. Then we have to form the differential equation by using some standard techniques or the fundamental laws or the physical laws, and then you will get the differential equation. So that differential equation, definitely it should be an ordinary differential equation of maybe first order or higher order. So we have to apply the different solution techniques and we have to apply the boundary and initial value problems. So once the model is formed, then the next step is very easy. That is how to find the solution of that mathematical equations or differential equation by using a different method. But we are more interested in particular solution as far as the application part is concerned. Look at this picture. The father is saying to his son, looks at the differential equation. Differential equations is everywhere. So the differential equation plays a very important role almost in all branches of engineering. So I would like to say engineering plus mathematics is everything and engineering minus mathematics is nothing. Thank you.